Good morning, everyone. Today we're going to be working on lesson 5.3. It's called Finding Unknown Measures in Similar Figures. What you should have before you begin this lesson, your notebook, a pencil, and a calculator. And what I expect from you. As you watch the video today, pause it along the way to write some notes down, draw some of the diagrams, and some of the examples along with the work. So you have some class notes with you so we can discuss them in class tomorrow. Um, so here we go. Let's begin our lesson. We have two figures that are similar. If you take a look at figure 1, the left measure in green is 6 meters, and its corresponding part is 9 meters. And we have another side here that measures 8 meters, and we'd like to find the missing side, x. So the corresponding side lengths are proportional, so we're just going to use a proportion to solve this problem. So how do we write that? Well, we can do the green, 6 corresponds to 9, and we can set that equal to the two red sides, and we want to go in the same order again. Since we went 6 to 9, small to large triangle, we want to go back and do it the same way, 8 to x. Okay, and at this point, we all definitely have the proportion skills to solve for x. 6 times x equals 6x, and 9 times 8 equals 72. So we can jot that down. 6x equals 72. And our goal is to solve for x. We want to isolate this variable. To do that, we want to undo times by dividing both sides by 6. And if you use your calculator and do 72 divided by 6, we will get an answer of 12 meters. So there you have it. Just a quick look at the word corresponding. We actually just practiced this at the start of this example. 6 corresponds to 9 because they're both in the same position. Same as 8 corresponds to x because they're in the same position in the two given shapes. New example. We have two quadrilaterals that are similar. The ratio of their perimeters is 12 to 5. Just a quick note, the first number 12 goes to the first figure, and the number 5 goes to the second, or the smaller figure. So since we already know one of the ratios to write the proportion, why don't we start there? 12 to 5. Okay, and it's also typed nicely up here for you. And we're going to set that equal to 15 to x. And notice the sides that I have highlighted in blue, those are the corresponding sides. This figure has been turned in relation to this figure here. 15 to x. And using your skills of solving proportions, we know that 15 times 5 is 75, and 12 times x is 12x. To isolate our variable, we divide both sides by 12. And using your calculator, 75 divided 12 gives you this 6.25. So your answer would be letter C. Okay, let's take a look at the next example. We have two quadrilaterals with the ratio of their perimeters is 3 to 4. Again, remember the 3 goes to the first figure, the 4 represents the second figure. So to find the value of x, we write the ratio that's been given to us, 3 to 4, and set that equal to the numbers that we do have to their corresponding sides, x to 12. Okay, this side x corresponds to this side 12. This figure is turned in relation to this one here. If you notice, 4 times 3 gives us 12, so 3 times 3 will give us 9. And if you don't like that way, we can still use the cross product. 3 times 12 is 36, and set that equal to 4x. And to isolate your variable, we divide both sides by 4. And we know that 36 divided 4 equals 9. So our value of x is 9. So this side here is 9.